So this will be the video key for spectral problem number 2. So I'm going to write in key here. And this time, I know I didn't do this with the first one, but I'm going to start with calculating the units of unsaturation. So 5 times 2 plus 2. And we have a nitrogen, so that's another plus 1. And then we'll subtract 7 divided by 2. So 10, 12, 13 minus 7 divided by 2 is 3. So we have 3 units of unsaturation. Now this particular NMR spectrum is quite a bit more simple than the first one. So we have a quartet here, we have a singlet, and we have a triplet. So we have only 3 different signals, so I'm going to label them as A, B, and C. So we have A, B, C. Integration is 2 to 2 to 3. We have a quartet, singlet, and triplet. And the chemical shift we have, let's say 4.3. Let me scroll back up. That's just under 3.5, so I'll just put 3.5. And 1.25. We have 5 different signals in the carbon NMR. Most of them are in the aliphatic range, but we have 2 that are higher up. We have one that is likely a carbonyl of some kind. This one could be an alkene or alkyne or nitrile. So remember that we have 3 different units of unsaturation. So let's look at the IR. This may be something, although it could be water. Water shows up around that high. We have a lot of CHs. These are likely going to sp3 hybridized CHs. We've got something here that's definitely an sp hybridized carbon-carbon bond, so that's a CC or CN. And then we have this. Now, this has to be a carbonyl, but it could be any number of different carbonyls as long as we have the right wave numbers. But if you look where this is, that looks to be around 1750 or close to 1750. So let's go back and look. I'm going to say that this one at 3500, that's medium. That's sharp. That's likely water. Then we have, and I'm just, this looks broad at, say, 2950. And we have another one that's maybe 2900-ish. This is strong. And although I'm going to call this broad, this is overlap. And that's SPCH. This is, I'm going to call this medium. Sharp. This is also sp3ch. Then we have, I'm going to say 2250-ish. Strong, actually. Sharp. And that's going to be either an alkyne or a nitrile. And then we have 1750-ish. Strong. This one is so strong that it may be broad-ish, but the only thing that can be is a carbonyl and likely an ester carbonyl. So something around 1750 has to be an ester carbonyl. Mass spec, if we look at our formula, C5H7NO2. So that's 5, that's 60, 7, 14, and 32. So 67, 81, 113. So that's probably there. That's M plus. Then we have one at 75, 80, 86. We have one that's, this is 70, this is 65, 66, 67, 68. So 113 minus 87 is 27. and then we lose another 14, so that's 41. So maybe 27, that looks like HCN, most likely. And this could be CN 14 and 12 is 26 and 15, CH3 perhaps. Now, let's start putting things together. So if we go back up to this, we likely have an ethyl group. So CH2, CH3, and if we have about 4 point, whatever that is, that's likely next to an oxygen. So this would have 3 neighbors. That would be a quartet. Between 3.5 and 4.5-ish. This would be a triplet. And that would be much further upfield, so that makes sense. So let's go down here and do an OCH3. Whoops. EH2CH3. And if we have an ester from our IR, we have something that looks like that. So we have one more signal, and that's a singlet with an integration of 2. So that's a CH2. So if we do a CH2 here, what remaining atoms do we have? So we have 1, 2, 3, 4 carbons. We have our oxygens. So we need one more carbon and a nitrogen. And we know we have a triple bond. So the remaining part of the molecule is likely going to be this. So we have our nitrile, we have our ester, and these two things account for 3 units of unsaturation. So this structure, we have ethyl group, triplet quartet, we have a singlet with CH2, we have an ester in the IR, we know we have a triple bond of some kind in the IR as well. This structure closely fits the information that we have. So I'm going to write out both ways here, sort of a Fisher projection. Now remember, when you're drawing triple bonds, keep them linear, keep them straight. That's the most appropriate way to draw them.